I would like to introduce Dr. Dan Arvizu. He's the director of the National Renewable Energy Laboratory. We're very pleased and honored to have him here with us today at the University of Colorado. Dr. Arvizu is director and chief executive of the National Renewable Energy Laboratory since 2005. And he is also an executive vice president of MRI Global. And he has been appointed by 2 successive US presidents to serve 6-year terms on the National Science Board, which governs the National Science Foundation. In the past, he has been a CTO of CH2M Hill, as well as being an executive at Sandia National Laboratories, among holding many other positions. And he also serves on a number of different boards and panels and advisory committees, including the American Council on Renewable Energy Advisory Board and the Singapore International Advisory Panel on Energy, among many others. So I hope that you would join me in giving a very warm welcome to Dr. Dan Arvizu.
Thank you. Thank you, Jake. I appreciate the opportunity to be here. I feel like we're neighbors. We're just down the road, not too far from here, just south in Golden, Colorado. It's where the lab is, and it's a really special place that I've enjoyed having the opportunity to be the director of for the last more than 10 years. And we've always had a great relationship with CU, and I just want to acknowledge that up front, that this is one of those kind of opportunities that we get to kind of share a little bit about what we're collectively doing. So I have got an incredible amount of information on this PowerPoint presentation that I'm going to provide you. I'm going to put it up on the website, and you can go to the NREL webpage and get access to the actual charts if you want. So you don't need to copy everything down, but obviously if you have some questions, now's a good time to ask, and I'll try to address those. So I'll try to fast forward through this about 40 minutes or so. I actually gave a portion of this presentation at the Vail Energy Conference, which was just held this past weekend, and there was a bunch of notables there, and it was very much an oil and gas centric sort of conference, which I'll talk about a little bit here. But it's primarily this is around renewables and really more about what I would call carbon-free type of resources, and a little bit about kind of where we are, what's the status, and where we need to go, what needs to happen, and kind of the things that it takes to kind of get us there. So that's kind of the 3 key sections that I'll get to. I won't have time to deal with it in any kind of real detail, but I've got a lot of detail on the slide, so we'll try to get through it as quickly as possible, and then I'll get to your questions, and we'll have a conversation about that. So let me start with context. So the first thing I would say is that, boy, what an interesting time we live in. A number of different things that I'll just kind of point out. I'll just make a few key points about each of these, and then I'll move on. First of all, the global renewable energy industry is growing rapidly. It's actually quite profound in how much deployment there's been internationally. It's well north of $2 trillion of investment over the course of the last decade, which is quite a significant amount. Most of that has been driven by public policy, and that public policy is in different parts of the world. I'll get to some of these issues later, but the U.S. started this whole thing with R&D. I started in the renewable energy business, gosh, in the late 70s, early 80s, and back in those days, we were making millions of dollars of investment. Over the course of the first few years, the U.S. probably made, I would guess something close to $1 billion worth of R&D investment. Subsequent to that, Germany in particular, Europe, made huge investments in public policy in the tens of billions of dollars, primarily through their feed-in tariffs and the technology adoption requirements that they put into place in their system. And then the Asians, and primarily the Chinese, put in literally hundreds of billions of dollars to scale up manufacturing, and we are where we are today as a consequence of those kind of sequential public policy events or actions over the course of several decades. The fast forward to today, we've got this incredible amount of unconventional gas and oil domestically that many people didn't see coming, even 5-10 years ago. They didn't see this, and today we are awash in that. I was working out at the gym this morning, and I saw that oil prices have dropped below, they're certainly in the 40s, and some expect they'll get down into the $30s a barrel, which is absolutely incredible. Who would have thought that just a few years ago? So anyway, there's a lot of unconventional gas euphoria in this country. That is not necessarily true in other parts of the world. And so down on the very bottom right-hand side here is just spot oil or spot natural gas prices. So in the U.S., we're down at the at the $2 to $4 a million BTU of natural gas. But you go to Europe, it's 10 to 12, and you go to Asia, and it's somewhere between 14 and 17. And so it's not the same everywhere. And so we're enjoying this little windfall right now, and we just simply don't know what will happen in the other parts of the world. We didn't get here overnight. This has been 25, 30 years in the making, and it's only after an incredible amount of technology application, both in fracking, which we've been doing really for a really long time, and horizontal drilling, and the accuracy of which has improved dramatically. So those two things kind of came together. We know our geology way better than the Europeans know theirs, or that the Asians know theirs. They all would like to have our technology so that they can extract those resources, but frankly, it's not clear what will happen. So that's a big unknown, and again, it's disparities geographically. Infrastructure investments will be made. So in the emerging economies, it's all about new infrastructure, demand's increasing dramatically, and they're making huge investments. In the U.S. or other developed nations, it is really more about aging infrastructure and the replacement of that aging infrastructure. So globally, it's somewhere north of $20 to $30 trillion of investment in infrastructure over the next several decades. In the U.S., that's a couple of trillions. We're about a tenth of that. And again, we're going to invest. The question is, on what? And I'll get back to that. And finally, the technology is creating a platform where there can be disruptive change. And this is, by the way, not unique to energy. This happens in healthcare. This happens in financial services. It is amazing how much disruption and change is occurring, and it's occurring primarily because of technology. And so you'll hear some words which I think, I'm on a board of directors of a major insurance company, financial services. And they talk about things that I'm resonating with all this stuff, different sector, regulated in a different way, but they're talking about things like creating option value, the commoditization of processes and products. So in our energy business, what that means is electrons are a commodity now, and you need to think about them as a commodity. And so you were looking at now, what are the new products and services that you're going to have to supply in the energy sector? Other words you will hear are things like differentiation, which means I need to have a valued product that people are willing to buy with new functionality. You'll hear disintermediation. That's another very, very technical term. What it means is the systems are really inefficient. So our electric energy system is really inefficient. By every measure, it's less than 50% efficient, or less than 50%, efficient. And really what that means is opportunity. So you've had players that have been in this value chain who are getting disintermediated. In other words, we're cutting out all the middlemen in this value chain. And so because of technology and the internet and a variety of other things, all of a sudden now you've got players, and think of that as consumers, who now have choices that we didn't have before. So the consumer can actually be a generator, right? So you put solar rooftop on, solar panels on your rooftop, and you get to be what we call a prosumer, right? Production and consumer at the same time. Business models will have to change as a consequence of those trends long term. So there's lots of angst about how that's going to look. I look at it, central station versus distributed generation, and that will be different in different regions. It'll happen at different paces, no matter where you are in the world and or in this country. So lots of opportunity for things to be different than they are today. I expect that they will be. All right, so that's kind of the opening statement. The second big thing I'll say, and I always say this, I've said this in every talk that I've given. I literally give 50 talks a year. It's really about a transformation. And you always get this I deal with Washington a lot. I go to Washington almost every week. I was there this week. I was there last week. And you get this question, what's the role of government? Should the government be involved? Well, frankly, the government's already involved. The government has been involved for literally 100 years. And it is a matter of on how well would the government play? So the first thing I would say is we really shouldn't be debating about which technology is better than which technology. It's not about that. It's about what do we expect out of our energy system. And on the left-hand side are the attributes of today's energy system, and on the right-hand side are the attributes that we should aspire to for the future energy system. And the role of government ought to be to enable this. The government does not have enough money to make this transformation on its own. It needs the private sector. This is uniquely a private sector play, but the government regulates, so the government has a role. And so part of it is how do you enable that right-hand side of this chart to happen more quickly? And I don't know that anybody would be against these things, but that is the future. This is where we are today. How do we get from the left to the right? That's the transition that needs to happen, and at what pace really is important. Okay, so that's the main thing. So one more snapshot. So this is some current information regarding where are we with essentially our energy mix. On the left-hand side is actually consumption, so it includes every sector of our economy, electricity, transport, everything else. And what you see up there on the upper, I got a little point right here, this little piece right here, all right, that is essentially renewable energy. Okay, that's hydro, and that's essentially non-fossil fuel energy that is in our economy. It's a little bitty piece. Okay, that's the takeaway from here. It's a little bitty piece. All right. There's some other things you can take away from here. This gray bar is going. That's natural gas. The darker ones. This is coal down here. Coal's shrinking. It's really at the expense of some renewables and some natural gas. Over here is electricity, and this is how much generation occurs. And you can see the thing that I told you about before. In our economy, our energy demand for electricity is flat, has been flat really for the last 7+ years, and you can see the mix in there. Things are so the upper part of that is the blue parts are renewables and CHP, that's combined heat and power. That gives you a little bit of a snapshot of what the mix looks like. Okay, so that's just data, and that's kind of where we are today. A little bit finer tune on the renewable part, and I give these talks all the time. I always get challenged about, you renewable guys always talk about capacity and you don't talk about generation. All right, this chart has both capacity and generation on you for those who want to know and see both. All right, so the upper one is really how much capacity we have in our electricity system of the various technologies. And so you see here, renewables is roughly 15% of the capacity. Now, and it's broken down like you have over here. That's, again, the capacity. This is the generation. This is how many essential electrons you actually generate in the course of a year. Here you've got, it's about 13% because the capacity factor for renewables is less than it is for some of the other technologies. All right, about 13%. Half of that is hydro, and the other half is all the other renewables. I call them non-hydro renewables. And that's what we generate. And this is 13 data. It's actually, in 14, the numbers are 1% comes from solar and 4% comes from wind. Okay, so rough numbers, wind and solar, the two biggies, 5% of the 6%, everything else is about 1% or so. And that's, that's kind of where we are. All right, that's a snapshot of the actual technology mix in the U.S. today. All right, the next thing I would say is that we're making investments. These are the investments that have been made, and this is global. So I'll get to the U.S. part here in a minute. But there was a huge ramp up over the last decade, and then of course this is the recession piece right here. There was a downturn for a couple of years, and now we're back up to about 300 billion or so. Most of it's mergers and acquisitions and those kinds of things. In fact, I've got some more data on that. The left-hand chart here is in what parts of the world are those investments being made. So you have first of all the green is Europe, Middle East. The blue is the Americas. That's North and South. And the red is Asia Pacific. All right. So you can see that back in the old days it was Europe, Middle East kind of dominated. Not anymore. So now what you see is Asia. Asia dominates pretty much all of it. And that's primarily China. Okay. By technology, you see it on the right-hand side here. The blue is wind. The yellow is solar, which is kind of where most of the investments are being made these days. And then everything else is called to the other category. So you can begin to see a little bit of snapshot, a lot of activity, a lot of demand in Asia, a lot of investment in solar. That's the two takeaways from those couple of slides. Okay, let me turn to the next phase of the conversation and discussion. That is, so what's possible here? We get lots of discussion about, and I always relate the fact that I've testified in front of Congress, gosh, a dozen times at least. In the first few years I testified, I'd get the same two questions every time. How much can I have? And you know, and when's it going to be real? So, you know, I keep telling them, all right, so it's already real. Maybe not in the U.S., but it's already real big time in other parts of the world. And how much can you have? That answer to that question is, how much do you want? Because frankly, every study that I've been a part of, which was essentially I was on the IPCC panel, I was on the global assessment, I've been, you know, the IEA has put a number of those things out. They've all said the same thing. There is enormous potential. Okay, that's the thing to take away from this slide. We actually did a much more comprehensive study at NREL with a number of partners, and this one is we looked at, okay, so we know it's a lot, you know, we kind of try to divide it up by, okay, what's the theoretical potential, what's the technical potential, what's the economic potential, can you actually do, all those things. We looked at that from a very, very systematic point of view. And so what we ended up doing was modeling what would the U.S. look like in the year 2050 if we wanted to have, let's say, 20% renewables. And then we did it again, 30% renewables, 40%, 50%, 60%. We did a parametric study all the way up to 90%. And what we concluded, and by the way, there was over 100 authors, 40-something organizations. These were the RTOs, these were the utilities, these were the regulators, these were all vendors. These were very knowledgeable people about how the grid works today and how it would work in the future and where the load centers are and where the resources are and how you would connect those. And we actually did this study. I'm going to show you an animation here. This actually is data from the study that we did to show, and I think it's launching over here. And what you're seeing is where in the country you see the black was fossil fuels, the orange yellow is more of the renewables, and what you're seeing is that in the year 2050, if you wanted to have 80% of your energy generated from renewable energy, could you meet the load on an hourly basis across the nation and have that be done with essentially technology that we know about today? No breakthroughs. You know, you need to put a little transmission in to get it from where the resources are to where the loads are. The answer is, yeah, you can do this. You can not only can you do it, you can do it at a minimal cost. And anybody who thinks they can know what's going to happen in the year 2050 is probably a bit, well, let me put it this way. I was going to say something that was very Colorado-centric, which I won't. But to say that it would be foolish to think that we know what's going to happen, you know, several decades from now, when frankly we don't even know what, you know, 10 years ago we didn't know what would happen today. So all that to say is that it is very possible, technically very feasible. It is not a matter of technology. It is not a matter of resource. It is a matter of business models, market conditions, and political will. All of those things are the things that really will drive this. But the point to make here is that plenty of resource, and it's really not about can you do it. You can clearly do it. And in fact, the question is how much are you willing to invest now, because you're going to invest. And you can invest in the things that will perpetuate the status quo. In other words, incremental investment, just replace what I've got now. Or get ready for the future, because the future is going to be very different than the past. And that's the key message that I want you to take away. I won't go back to the other sector because there's a lot more to be done. So at our laboratory, and really within the Department of Energy, what we've been doing is looking at what are the key features that you need to do. So there's all kinds of questions, and people are saying, well, you put all this renewable stuff on the grid, and the sun doesn't shine all the time, and the wind doesn't blow all the time, and the intermittency is a problem. Well, the intermittency is an issue, and it's an issue if you think about the world in today's context of, this is my power plant, I've got a big power plant, I've got big wires that connect that, you know, it all flows downhill, and at the end of the day, I get one opportunity to plug in and demand energy at this level here. If you think about a different world, then intermittency is not so much of a problem. But if you have the old think, you're going to have intermittency as a problem. So what are we going to do is we're looking at what are the things that really drive us. So everything from the perspective of, you know, the public policy that's in place now, the renewable portfolio standards, which obviously we have one here in Colorado, they have one in California, they've got them in 29 different states. And then you go back and you look at what do those technologies actually do, how do they affect the system, what would we need to do different? And we're starting to look at this in a very, very comprehensive sort of way. And what we were determining is, oh my gosh, there are all kinds of really neat things that you can do. So as we go forward, this is really about developing a vision for the future that's very different than the vision that we've had in the past. I mean, our energy system has served us well for 100 years. Let's just face it. We've got lowest energy prices in the world. It's really not bad. The problem is it's not sustainable. It's aging. It really is not going to serve us for the needs of the 21st century. And more importantly, it makes us vulnerable. It really is. There's a lot of reasons why it's not a good system. And so as we think about the future, what should that system look like? And again, recognizing technology is going to make a difference. It's making a difference in every sector of our economies. Why we wouldn't think this in this sector is, again, would be very short-sighted of us. So really, innovation is going to be king here because it's going to drive options that we didn't think we had before. It's a little bit like telecommunications. You know, I started at Bell Labs many, many years ago when AT&T was a monopoly. I was at Bell Labs and we were building stuff and it was great. And we thought, gosh, what an awful thing for the government to break up the Bell system and create this, chaos in the IT industry or the telecommunications industry. Well, you look back, and it's a similar situation to what we have today in energy, primarily because telecommunications is, it doesn't really cost much to make a phone call these days. However, we don't use our phones primarily as an instrument to do, I mean, it's our connectivity device. It's got more functionality than making phone calls. And in fact, the phone call part is really, really simple and very, very inexpensive. It's all the other stuff, all the other functionality that we got that we didn't realize we needed and wanted and otherwise made our lives more simple. I think this will be the same way. So technology, acceleration of moving to this new future rather than letting the system clunk along. Whenever you have a regulated environment like we have for energy, it's devoid, literally, of innovation, and because you don't invest. You don't allow the players to invest. The amount of R&D in this sector is 0.8% of sector sales. There's no sector of our economy that could function on that as a matter of free market forces, primarily because that's your seed corn. That's really where you want to go. So again, accelerating the market adoption. The other piece of this is integration at scale. I mentioned earlier that this sector is incredibly inefficient, and it is. If you look at the assets that we have that generate electricity in this country, and you look at the demand, and you look at how much of the time those assets are actually being deployed to meet the demand, it's less than 50%. So we have 50% capacity factor on our asset base. Right? There's not a sector in the country where 50% asset utilization will give you any kind of favorable business condition. I mean, that's an awful record. So you got to find a way you're deploying all this capital, and then you're not getting the value out of that capital production. So that's just the nature of a regulated, essentially, utility slash system we have today. Driven, again, by public policy and driven because we thought that was a good thing 100 years ago. We can do better, and there's a whole bunch of other things that we can do. And again, this is going to be something that's got to be a public-private partnership. It has to be collaborative. There is not enough money, certainly not in Washington, and I think even across the country, for us not to work together and leverage what we have. It's about capital. We're going to spend $2 trillion in the next 2 decades. The question is, on what? All right, so let me just say, at our laboratory, one of the things we recognize, and this is the Department of Energy, I think, mandate for us, is that we cannot do this. This is not government comes in, does a bunch of really gee-whiz stuff, throws it over the transit, hope good things happen. We're past that. We now have to work in partnership with industry. So at our lab right now, we have over 400 active partnerships. This is a few of the logos of the companies that we work with. And it's primarily because they know what's going on in the marketplace. And if you're going to marry the R&D, technology development stuff, you put it with this stuff here. All right, that's the point. Now, I wish I could go through all of the components of the work that we do on the generation side, on the end-use side, and everything in between, which is the interconnection and distribution. I will not be able to do that. What I'm going to highlight is the biggies: solar, wind, analysis, and systems integration. Those are the big four that I spend most of my time, and I think the community spends most of its time thinking about. We do a lot of other things. We do vehicle efficiency, we do building efficiencies, we do a variety of things with biofuels, we do things with geothermal, we do things with hydrokinetic type of technologies, and there's some great stuff going on there. I won't talk about that today, but the lab does it. I wanted to make sure you understood that. All right, solar. It's the darling, it's the one I have the least amount of trouble with typically trying to sell in Washington. Everybody kind of gets this idea, and when they think of solar, they don't really think of the big solar thermal facilities, which is kind of where I started my career, but they think about elegant photovoltaics. Sunlight in, electrons out, no moving parts, semiconductor, great stuff. It really is cool. All right, so when I started in the business, literally late 70s, early 80s, we would celebrate when we would actually deploy a 10 kilowatt system. I remember the first 10 kilowatt system, we actually put it in Riyadh, Saudi Arabia, believe it or not. It was a concentrator system, I'll never forget, because it was a huge deal, 10 kilowatts. All right. We went from kilowatt deployments to megawatt deployments, that's 1,000x. And now we're talking about gigawatt deployments, that's another 1,000x. And if we're ever going to get to the outcomes that I think we can get to, we need to go to terawatt scale. It's another 1,000x. Amazing in my career that this has gone from kilowatts to gigawatts. Well, there's 20 gigawatts in this country already. There's 200 gigawatts globally. Amazing amount of deployment. And it's, you know, and the costs are coming down. I'm on an advisory board in Dubai, and they just did a deal for a 200 megawatt system at 5 cents a kilowatt hour with no subsidies. Absolutely incredible. This technology is moving, and it will be, we're just at the tip of the iceberg. 1% of our energy generation comes from solar. It could easily be 20, 30% in the next couple decades. All right. This chart's important because, so who's getting the benefit of all this? I mean, so we got 200 gigawatts of deployment going on. Well, so global manufacturing is dominated by China. And, you know, it's technology that we pioneered in the DOE program in the early 80s. I was part of that. I funded most of those technologies at the various universities around the country. And now we are buying panels from China. All right, now public policy drove this. All right, and that's important. And so when I go to Washington, they'll say, well, gosh, we make all this investment, and then, you know, we're buying stuff from other people and getting the jobs, right? Well, so that's true. That's the bad news. The good news is we're at 1%. We're at 1%. We need to get to 10, 20%, which is, again, 1,000x from where we are. This is not the technology that's going to take you to terawatt scale. The technologies that we're dealing with today are not the technologies that take you to terawatt scale. Those technologies are the ones that are in the laboratory today. And these are the things that we're working on. We're working on thin films. And many of you know about First Solar. They're the ones, by the way, that did this 5 cent a kilowatt hour technology that I talked about in Dubai. We're talking about, you know, the interesting thing about these technologies, what we've learned is that we brute force this. It was a little bit like driving a truck instead of driving a sports car. The business end of a photovoltaic device is in the first few microns, nanolayers of atoms. The business, the real action takes place in that first few monolayers, and it can be really, really thin, and you can put it on a flexible substrate, and you can really make it advanced manufacturing, and you can really do fast throughput. The technology of today is the old clunky Model T, and we can still do Maseratis later, right? So we're a long way from anything that resembles what will ultimately be the technology in the marketplace. And it will be dirt cheap. It'll be really inexpensive. So the good news here is, as we learn more about technology and the physics of molecules and physics at the nanoscale is really interesting because many of the physical laws change when you get to the nanoscale. So nanostructured materials is huge, and we're doing all kinds of stuff. And in the laboratory, there's more innovation going on today than anything I saw literally 30 years ago when I was a researcher and actually did real technical work back in those days. It was mentioned, Jake mentioned that I'm on the National Science Board. One of the things that I find really, really fascinating is, so the National Science Board has a $7.5 billion budget. The board actually approves this budget, so I know it quite well. And I testified in front of Congress just a couple of weeks ago defending this budget. One of the things that I would say is that if you just, and their mission is discovery science. It's go push the frontiers of knowledge. So I rolled up, we looked at what is NSF doing in their budget that relates to clean energy. And they're doing a lot. They have over, I think the number we came up with was like $377 million of work that's going on, PI-driven, that means principal investigator, at universities. And they're doing some really cool stuff that are not yet making it into the DOE's program because it's really revolutionary. And so here's kind of one. This one here is something that Michigan State's pioneering. Transparent solar modules. I mentioned that it was really, really thin. All right, so this technology uses the infrared part of the spectrum to generate electricity, but it's transparent. It's clear. It's just a looks like a plastic lens kind of thing. And this, again, is the precursor to building integrated PV, where you put it on all services. This is not that far away. I mean, it's, you know, people remember they used to think about driverless cars and the technology being something way out there, you know, Jetson kind of. No, that stuff's here today. And these kinds of things are here as well. And I just wanted to point out the fact that in our innovation ecosystem, there's a lot of work going on, way beyond what the Department of Energy does in this arena. And there's some other things, I won't go through these in any detail other than to, you know, they're really cool research projects, first of all. Second of all, they have a very, what we call use-inspired, an application in mind, and we're harnessing the minds and the research prowess of the entire country to do some things that are really revolutionary, and they're going to feed into this ecosystem. And this is going to be the technology of the future. When we get to terawatt scale, expect that many of these things that got funded under NSF grants are going to be the things that are actually driving the technology in the future. So I'm excited by that because it's just, I can see, I can connect those dots for me. That's really great. Wind is kind of the big player right now, 66 gigawatts domestically, 370 gigawatts globally, and still going strong. I mean, there's still places, and in fact, most of it's going to be offshore, just because I think that's where the next resource is. Already, it is really, in a windy place, it is really inexpensive. And the capacity factors are like 50%. It's not like it's, you know, solar's more like 20, 25%. This is more like 50% in windy places, which is a big deal. I mean, that's a huge factor. I can remember when we did turbines in the early 80s, and the wingspan, the rotor diameter was 1.8 meters. Okay, it's 1.8 meters. It's just like almost 6 feet, right? And today, the big machines in the 5 and 6 megawatt scale, the big machines, 140 meters. Okay, that's a football field and a half. You can put two 747s, wingspan to wingspan, in the rotor diameter of these big machines. Absolutely incredible. As a mechanical engineer, I'm looking at these things. I don't know how they. Oh my gosh! It's like defies logic. The nacelle, the big piece that sits at the top right here. I went to Europe and saw a 6 megawatt machine. It was 280 tons in a hogged-out cast facility, putting these things, and that's 140 feet in the air. I mean, absolutely incredible stuff. The fact that they work is mind-boggling to me, and they generate a lot of energy, right? So the technology has moved very, very quickly, and this is kind of where it's deployed. Again, China, where else? You know, they've got a demand. And there's lots of really, really cool stuff that's going on in even these areas. You know, again, we've come a long way, and they're primarily base load for Central Station, but now we're looking at a variety of things. I mentioned offshore wind. We're looking at floating platforms, and guess who is the primary players in that? Well, it's the people that do offshore drilling for oil and gas. They know how to do floating platforms, and they do it really, really well. And they're looking at these things, and they're already engaged, and those companies are already starting to morph that way. Lots of technology opportunity for improvement. Most of this is going to be done in the private sector, and it should be. I think the labs have great opportunity to provide new insights that possibly couldn't be done by the private sector. All right, I mentioned analysis, and you know, two big things have happened in my tenure at NREL in the last 10 years that are really, really important. One is we decided that it was important that we understand the marketplace well enough that we could actually inform the R&D agenda, because we only have limited resources, and inform what is the appropriate government role to really accelerate adoption of technology. And so analysis was important. This is not just about technology. I mentioned in that other slide, it's a technology, it's a regulated environment. So you got to deal with policy, and you got to deal with the biggie, which is markets and finance. It's really, you know, when you get right down to it, it's all about the money. And it's, how can I make an investment and get a good return on my investment? That's what the finance community cares about, and for the most part, that's what drives this sector. And so you got to de-risk. So the role for government is to de-risk the investment strategies of these financial players. And so the main thing that we're looking at is, all right, what can we do to have this be a really attractive investment? And that comes, it comes in the form of policy as well as technology, as well as a variety of other things. I mean, it's amazing to me how there's the newest thing in finance these days is yield codes. I'm not sure if you've heard of those things, but it's that you package assets, and you package those assets, you know, you need the finance people to go, you know, kind of watch this, because it's really quite interesting, but it becomes an investment instrument. It's like an MLP, a master limited partnership. But it's a complex financial mechanism that allows you to mobilize more capital. Really, really quite dramatic because it's a real sector. It's a real sector. People are making real decisions based on that. Our role is to figure out what are those pieces that allow us to accelerate. Let me just tell you a little bit about our analysis capability. So we started here on the left-hand side. We started with doing this left one is techno-economic analysis. That's pretty sophisticated stuff. You look at the process steps in manufacturing. This happens to be lithium-ion batteries, but we've done it for the other technologies. And you look at, okay, process step by process step by process step, how much they cost, how much should they cost. Typically, they should cost a lot less than they do cost. And you do a bottoms-up analysis on what the ultimate cost should be. All right? That was the techno-economic analysis. Then we went to the right-hand side, and we said, you know what? It's not just about the widget that you make. It's the global supply chain that goes along with it. If you're making photovoltaic cells, okay, you buy silicon in the U.S., you know, big refineries, those kind of things. You ship them to Asia, and they do essentially value add as they put different components together, and then they ship modules back to the U.S. to the market. All right, so this is the global ecosystem, and you make money at the different steps, and you need to understand where do you make the money. You know, one thing that what we've figured out is right now, all the PV manufacturers are losing money on every module that walks out the door because the prices are less than, because there's a glut, there's more manufacturing capacity because that's China overbuilt, than there is demand, so the prices are below their marginal costs. Well, that's not a good business model, right? So what do? You vertically integrate and you make money in the other steps of that value chain, in the supply chain, right? So the global supply chain is really important. That's where the jobs are, and that's where the money gets made. And you need to understand that piece of the equation in order that the techno-economic stuff makes any sense to you. And then you can do what we did down here, is the comparative analysis and say, if I build a factory in China, what does it cost me? If I build a factory in Nebraska, what does it cost me? And is there really a value in the difference in the cost of labor or in the transport that goes along with that? And so now we're looking at that from the perspective of, and by the way, the answer to that is, next generation technology doesn't matter where you build it. It does not have to be in low labor cost states. It can be in the US, that's the key point. All right, the next thing we went to was, okay, so now we've got technology, we've got comparison by region. What about comparison by technology? Now I'm looking at, okay, I got solar PV that's made out of silicon, I got solar PV that's made out of cadmium telluride, I got solar PV that's made out of copper gallium diselenide. I've got all these various technology differences that have different values to them, and now I can begin to do a comparison that really provides me some really insight about where do I put my R&D money, and where do I make my investments? Those are big, important things. And then finally, the last thing over on the right-hand side is for the policymakers, which is, so you got all these levers that you can turn. So this is a sensitivity analysis. Those of us that are engineers recognize you got to do a lot of uncertainty analysis. So what's the value of this particular variable, whatever that variable might be, and we're looking at, so what's the sensitivity of your outcome to that particular variable? All right, I see I'm about out of time. I'm going to fast forward. The last thing I'll say is about systems integration, because frankly, we've had this old model of big power plants, big wires, one-way power flow, and it's really quite interesting, but it's really inefficient, okay? And so you've got folks that, that kind of know that model, and they make money at that model, and they don't want to change, all right? And you've got regulators who are saying, I just want the lowest cost of energy, and I got to protect the consumers, and you've got technologists saying, oh, we got all these other opportunities, and you've got the finance community saying, I don't know what's going to happen here, but I'm going to be ready. And so there's all these things that are part of the business, and part of that is, how do you integrate new technologies into the system we have and start to morph it to the technologies that we want? This happens to be, we've got a $20 million effort at NREL. That's actually a $200 million effort at the Department of Energy. And here are some of the key takeaways. Variable supply, variable load. We used to be able to deal with variable load. That's us plugging our stuff in and out of the wall socket. But now we got variable generation. If you think that renewables are going to be a big player, then now I've got variable generation. Can I match variable load to variable generation? That's a very important thing. Increasingly, if I'm putting solar on my rooftop, I'm not competing on a dollar per watt and or cents per kilowatt hour with utility baseload. I'm competing with what's on my electric bill, okay? So in Colorado, we're blessed with good prices, but I'm competing with 4 cents kilowatt hour for the first 500 kilowatt hours, or 4.5 cents, or 9 cents after I use more than 500 kilowatt hours at my home, it's cost me 9.2 cents kilowatt hour, okay? So if I can displace 9.2 kilowatt hour energy, that's my marginal cost. Never mind the fact that the utility is generating it for 2 kilowatt hours, 2 cents kilowatt hour, and then shipping it to me, prices go up, go up, go up, go up. By the time it gets to me, it's 9 cents, all right? I'm not competing with 2 cents. I'm competing with 9 cents, all right? That's my distributed piece. And as a prosumer, as a consumer that's generating, that's my economics, all right? So that's the new normal. That's going to be where we go. So this changing role is a very important thing. There's lots of things you need to do that, but one of them is measurements and control. I mean, everything is smart these days. Everything has an IP address, and you can measure it, and you can collect the data, and you can synthesize that data, and that data is really important because it gives you differentiation, and then you can price products as a consequence of market conditions, and then you can control things, all right? That is happening in this sector, like it or not. And this is the new future. So all of that saying that there's things that are changing. So the Department of Energy has a thing called the Grid Modernization Initiative, which both NREL and Pacific Northwest Lab are leading. We're leading all the national labs to do that. And it's a big thing that the Secretary just presented. It's in our FY16 budget. We've got about $200 million already being spent in the Department of Energy on this. The FY16 request was for $350 million, an extra 150 additional. And I was walking the hills, the Congress the last few weeks. They get it, and this is going to be a new big thrust in terms of new investment I think that the government will make. It's important because it's everything so these are the technology pillars. It's everything you see up there. It's complicated, but it's also incredibly, I think, there's great opportunity, let me put it that way, for what happens next. Let me say a word about Colorado, and then we'll take some questions. So we have a number of things, and we're really blessed in this region because we have a number of research institutions along the Front Range that are, I think, players in this whole energy system area. And specifically, a few years ago, NREL, CSU, and CSM all came together and formed this thing called the Colorado Collaboratory. And this Collaboratory is kind of a very interesting little mechanism that we all essentially, I think, collaborate in a way that allows us to attract more money. So the state actually put $6 million. I'm on the authority board myself, and the presidents of the 3 universities are on this authority board. And we oversee this investment that the state has made. For $6 million that the state has made, we've made a significant, and I've got my notes here so I won't misquote this. We've made significant progress. In the Collaboratory, we have over 100 and, let's see, we have 64 industrial partners. And overall, $6 million from the state, $12 million from the industry, $37 million from the federal government has allowed us to really have, for the $6 million that the state invested, an 8-to-1 leverage. So for every dollar that came in, we were able to attract, essentially $8 other dollars from other technologies. We have 4 centers: the C2B2, which is the biorefining and biofuels; Center for Revolutionary Solar Photo Conversion, that's called CRISP; Center for Research and Education in Wind, called CREW, and the newest one, Carbon Management Center, which is CMC. All of these centers are just clusters of things where we can go and professors and scientists and grad students and researchers from these institutions can collaborate on things that I think make a huge difference. One of the things that I also am very, very proud of is we just recently won this thing called ICAM, which is kind of about manufacturing, but really it's about carbon fiber as a technology for multiple applications. And Colorado won one of the centers. So there's regional centers. There's one on vehicles, compressed gas, and there's another one in Tennessee and in Indiana. And it really is quite fascinating because it has brought together literally a whole bunch of partners. This is the one that has 100 and something members to it, 122 members in the consortium. Almost $200 million of private sector money, okay, partnered with $70 million of DOE money. So it's a big deal. And then divide that equally among those various technologies, and that's how much we get in our one here. And it's really going to make a difference from the perspective of it is kind of the next generation of materials, right? So it's a base material. Carbon fiber is a material that allows you essentially to lightweight vehicles. And in the case of these massive turbines for wind, it allows us to lightweight these massive turbines. The turbines are the cost for these wind turbines is primarily materials. And you know, I used to just, a rough number is like $2 a pound. So however how much it weighs, that's how much it's going to cost. It's because it's about, you know, it's mostly made out of metal. And then now we're going to these new technologies with carbon fiber, which is a really important thing. And a sister consortium that we've put together as well is this renewable carbon fiber, which is using biomass actually to create a kind of an intermediate material, which I think is also incredibly interesting, this acrylonitrile, otherwise known as ACN. And essentially what you do is you take biomass and you break down the molecular structure, put together sugars, and then you upgrade that with separations and catalysis, and you get essentially a biomaterial product that now can feed into this carbon fiber technology. So now you kind of have a full circle of the ecosystem so that you really begin to look at kind of the next generation. So this stuff is happening. It's happening now. CU is a big partner of ours and a number of others. So let me just end with this. Innovation is changing the way we live across all sectors, no different in energy, in fact, probably more so in energy than anyplace else. We do have an opportunity to invent the future that we want. Because frankly, again, this is a sector that's been highly regulated, and it's easy to say, you know, gosh, it's great. We got this natural gas. We got, you know, we're lowest energy prices in the world. Let's relax. You know, we're good to go. Things are good right now. And that's a very short-term sort of thing. We need to be preparing for the future. And the future has a whole bunch of other attributes to it that are very different than today, and we need to be about that. And so we need to aspire to that. It's not sufficient to just say, let's just muddle along, the market will take care of it. The market won't. The market will take care of what the market signals demand it for. And right now, we don't have market signals that change too much. It's making progress, but not as much as we'd like. Access to capital, it's about the money. It's about investors making investments and getting a return on investment that's attractive. And in order to do that, we've got to do some things different. And then finally, it's you know, we've got commodities here. Let's partner. Let's learn from others. Other nations are doing, frankly, a lot more than we are. We still have the technical prowess advantage. We're still the best in terms of innovation, but we're losing that lead very quickly. And I think if we're ever going to get back into a position where we really have global leadership, we need to do that differently. Okay, that's all I have. Thank you for your attention, and I'll be taking some questions.
Thanks, Dr. Arvizu. I thought that was a very well thought out synopsis of the state of clean energy, especially in the US. And I particularly appreciated one of your main points, and that was that the technology's there, it's more a question of implementation. So that led me to choose two questions to ask first. And that is, since you mentioned that policy is a very large driver for clean energy, what is the most important type of policy related to clean energy? And also, what types of arguments have you found most persuasive in creating political will where it does not previously exist?
Great questions, and ones we struggle with all the time. I think the first thing that I would say about that is, you know, you need to give policymakers the tools to make decisions. And what we have found is that this is a very complicated area. Every region of the country is very different. That's why we have literally 50 different energy policies in this country. It would be nice if we had one. I kind of given up on that, to be honest with you. Going back to Washington and trying to get them to agree on what the national energy policy ought to be. Well, we've been talking about that since Eisenhower, and it has not happened. What I see today, though, is what I'm calling grassroots. It's ground up. It is from the consumer level up. And it's happening at the regional level, primarily at the state, but regional level, sometimes city by city, sometimes region by region. And the things that are compelling is it's about local economic development. That's what people care about. People care about, you know, what does it look like for me? Every region of the country has different resources. They have different business climates. They have different costs of doing business. They have different approaches to how they attract businesses. All of those things are part of the calculus that's necessary to make a decision on policy. So the people who are making decisions right now, who are really essentially, I'm calling it ground zero in terms of policy, are the PUC regulators. So this is in the case of Colorado, it's the Colorado Public Utility Commission, right? And so Josh Whippel is the chairman of the commission, and he and I literally we have lunch at least once every several weeks. We stay closely connected. He's got a tough job. He's got to make decisions about what are we going to do here in Colorado, and he's got lots of constituents, but they have a couple of basic things. Is, protect the consumer. Not, we want to let the utilities have a reasonable rate of return on their investments, but ultimately they've got to kind of make the decisions about which direction we head. And I've participated with the Public Utility Commission a couple of times here in Colorado, with other commissioners, by the way, from other states, to share what are the best practices. What are you doing in Nevada? What are you doing in Arizona? What are you doing in Minnesota? Because they're all different. And one kind of big aha came out of the last one we just had, which was just a couple of months ago. And that was the decisions that you make on public policy really depend on your view of the future. If your view of the future is, I got what I need, I don't need much more, I'm just going to make incremental improvements, well, guess what? Your policy is going to reflect that. In other cases, I don't think that this is what we need to do something different, then your policy decisions will be different. And so you need to understand where you're headed and why you're headed there. The fellow from Nevada, the Public Utility Commissioner there said, we know what our public objective was to create a local industry. That's what he said. And he said, so our public policy essentially requires that. So that's because they know what their objective is. And so turning it back on the other commissioners, you got to ask the question, what's your objective? What are you trying to accomplish? And it's unfortunately locally driven. It's not happening at the national level, it's happening at the local level. So those are the drivers, and I think we're making progress. We're making progress despite the fact that we can't get a national strategy, so to speak. Again, I don't think that's going to happen anytime soon. And so it's about local economic development. That's the biggest driver. It's really not so much about some of these other things. But everybody likes the idea of having a little bit more autonomy, having a little bit more control, having a little bit more decision making, not totally be dependent on somebody else. I think those are all drivers.
Thank you very much for your answer. I'm going to be a little bit greedy here and ask one of my own questions, but it does combine a lot of the components of many of the questions we got about how we can transition to use more renewable energy in the future. And I know the Renewable Energy Future Study is a fantastic report that is very comprehensive, and it looks at the problem and what we need to do in the future from many different angles. But one of the issues is that in order to tap into the resources that we have, where we have a lot of the renewable energy potential, both offshore and in remote areas where there's a lot of wind or a lot of solar, we need to either install a lot of transmission or install these offshore wind plants. And so what do you see as the biggest barrier, and what do we need to do in order to tap into that resource?
Yeah, that's another great question. It doesn't have a simple answer, unfortunately. There's a lot of different things that can happen. Some of them are technology driven. So you mentioned offshore wind. We've had kind of a prohibition on offshore wind. I think we have 0, right? I think that's our number, 0. Europe has something like 100 or something gigawatts. I mean, they're moving. They're doing a bunch of stuff. It's still expensive, and so you need essentially a little bit of support on developing the technology still. But there are companies that are doing that. That's attractive because you don't have to build new transmission. And offshore, and you can go 20 miles offshore, and you cannot see the turbines. Okay, so no matter how good eyes you have, they won't show up on the horizon if you're onshore looking offshore. And that's a 20-mile cable is not a big deal, and you don't have to build transmission for that. And more than 50% of our population is near a coast, right? So the load centers are there, and you don't have to build transmission. It's kind of attractive, and you don't see it. So it's a matter now of just getting the technology. So that's a technology fix. In terms of some of these other things, and you mentioned the transmission primarily, and that I've talked to a number of utility executives, and I've been part of the California. I mean they're moving quite quicker than most other states. And the utility executives say, building transmission, That's a 10-year deal if you can do it at all. It's really hard. It's the NIMBY stuff. No one wants to see big transmission wires in their backyard, right? So there's a prohibition on that, primarily because of public sentiment. They just don't like it, all right? So that's a barrier for building transmission. The other part of that is, Governor Brown just announced they want to go to a 50%, renewable portfolio standard. Well, the utilities were quite concerned about that. They did a study, and I was actually part of their what they call the independent advisory panel to evaluate the parameters of that study. But if they go to 50%, it's going to be mostly solar, primarily because they're pretty much tapped out on wind. They've shut down, the nuclear plants. They've taken away all their once-through cooling fossil fuel plants. They've got an agenda that they're moving on, and the question is, how do you do that? Well, it's not going to be with transmission. It's going to be distributed, and even though I think it's popular to say it's going to be rooftop, there's a smarter way to do it than just do rooftop. And so now you need to think through what are all the implications of how do you scale up, how do you deal with that. So you've got a couple of things. Demand-side management is a huge piece of this. In other words, what are the incentives in the marketplace to make sure that you can essentially manage the load better? The way you manage the load better is to send market signals. If you're a commercial business and you tell me if you use your energy at night, it's going to be half the cost if you use your energy during the day. Well, I'll shift stuff to the night, right? So those are the kind of things demand-side management offers you, and storage is the same thing. So storage is kind of in one of those areas. Right now, the storage costs are still coming down. They still need a long ways to go. It's not really playing in the marketplace, but it could be really disruptive, especially small storage at the home level. So there's lots of things that are going to change over time to inform these decisions. But it starts with regulators. It starts essentially with technology, and ultimately with a value proposition that really makes money.
Unfortunately, we only have time for like one more question. Okay. But this one's interesting given the current oil and gas prices. So Elon Musk a couple weeks ago said the demand for electric vehicles isn't going to change much with lower gas prices. And right now, natural gas is like below $3 and oil is around $40. What do you think about that? Is the price of oil and gas going to negatively affect our innovation in renewables?
I think the one thing I can tell you about predicting, the future of oil and gas prices is that no one really knows that, and if they think they do it, I think they might be suspect. I don't think at this point. Now I've watched a number of cycles where, in the 80s, oil prices went to $12 a barrel, and the government cut the national program almost out entirely and reduced it. I mean, NREL cut its staff in half in the early 80s because of oil prices going down. We've had multiple cycles since then. I view this cycle as being different. It's different because we've got $2 trillion worth of investment. You've got investors who are already recognizing the value that it brings independent of. Oil is primarily related to transportation. Electric vehicles is still a very small part of that transport. I've actually had dinner with Elon Musk. I've spent several meetings with him. He's a visionary, so he's one of the people I would invest in. If I had a lot of wealth, I would do that. But on the other hand, it's hard to know exactly what's going to happen. I don't think the oil prices that are today making, I think, huge disruption in our geopolitics for sure, and creating lots of havoc for the oil and gas industry. In fact, the oil and gas executives that I was with this weekend said a couple of things which I thought were important. Oil and gas drilling, when you drill a well, it used to be that 70% of the well was the cost of drilling and 30% was completing the well, they call it. They're not those numbers today are flipped. 30% to drill the well, 70% to complete the well. So when oil prices drop like they have, they're still drilling the wells. And that's to be ready for when the price comes back up, and then they will complete the well. So I believe it's inevitable that prices will come back up. I don't know how long that'll be. It could be soon, it could be later. But we're still going to be saddled with the same exact issues in our energy system. And I know that not everybody agrees that carbon management is important, but carbon management is really important. I can tell you as a scientist and as someone who's looked at this from every perspective that one can, that is not debatable. We've got a problem with carbon emissions, and we're going to have to deal with it. And so whether you do it now or you do it later, you're going to deal with it. And part of, I think, what we need to do is to put our public policy in place that says carbon is important, carbon management is important, even if you had natural gas forever. By the year 2040, you better be taking the carbon out of natural gas or we're in trouble already, all right? So it's as though it's inevitable, it's going to happen. You know, the prices may actually slow the amount of investment that's made in renewables, but the genie's out of the bottle. I don't think at this point now, if the U.S. doesn't continue to invest, we will be buying our stuff from the other parts of the world. It's that simple. So to me, it's an imperative. We absolutely have to do it. And so I don't think there's a choice. And part of my shtick is to make sure that we get the message out. This is not hard to understand, but it does take a little bit of vision and will to actually actually make it happen. Okay, thank you for your attention.
Thank you again, Dr. Arvizu. We wish we could ask you all the questions that we had, but time is limited and we must push on with our schedule.